In this video, I'd like to talk about the concept of surface area. And before we look at an example problem, let's consider what the definition of this concept actually is. So surface area is how much total area the outside of some object occupies. So if we consider a box, like this cereal box here, we want to know how much total area just the outside of the box takes up. So we're not concerned with the inside of the box, which is the concept of volume. We're concerned with just the outside. So maybe the front side, the back side, then both the right and the left side, which you can't see, but we could also include that as well. And then the area of the top and the area of the bottom. So if we add all of those together, the area of each of those sides, we would get what's known as the surface area. So let me paste in a definition and a more specific example problem here. So again, it's the total area of the surface of a three-dimensional object. And they give the example of a cube. So the surface area of a cube is just the area of all 6 of the faces added together. Since in a cube, remember it has all the same dimensions for length, width, and height. So each of these faces would have the same area. And to find the surface area, we add them all together. And this blue diagram here, this is just a picture or a representation of what would happen if you essentially cut out the cube and opened it up. So this would be the top of the cube, and then these are each the sides of the cube, and then this is the bottom of the cube. You can imagine folding this back up, and then all the pieces or all these sides would also fold up to meet this top face. So this is just what it looks like unfolded, but the surface area, essentially, we're just going to find the total area of this shape when it's unfolded. So with that in mind, let's now look at this specific example problem where, again, we have a cereal box. And this is just a rectangular prism, or a specific example of one. And we need to find its surface area. So rectangular prisms are essentially composed of 3 sets of opposite rectangles. So what I mean by that is that we have the same rectangle on the top, and if we drew in the bottom, I didn't draw that very well, but if we drew in the bottom, that would have the same area as the top because those have the same dimensions. On the top, this would also be a 15 by 4 centimeter rectangle. And then the left and the right are going to have the same rectangle as well. This is a 4 by 25 rectangle, and if we drew in the back one, which you can't see, would also be a 4 by 25 rectangle. So we'd add in those areas together. And then lastly, we have the 2 opposite rectangles on the front and the back. So you have let me draw the back one in first, since we can't see that one, but that rectangle, I didn't draw it that well, would be a 15 by 25 rectangle. And then you have the rectangle on the front, which is also 15 by 25. So it has these 3 sets of opposite rectangles. So essentially, we find the area of the front and double it. We find the area of the right and double it. And then we find the area of the top and double that. And adding all of those together would give us the total surface area. So let me write this out a little bit more explicitly. We have twice, we can say the rectangle on the bottom or the top, which is a 15 by 4 rectangle. And then we're going to add to that, let me use a different color, twice the rectangle on the side. So on the right and the left, this is a 4 by 25 rectangle. That's this one right there. And then we also have the rectangle on the front. So we'll add twice that rectangle as well. And this one is a 15 by 25 rectangle. And if we add all of these together, we get the total surface area, or we'll just call that surface area of our rectangular prism. So let me make a little bit of space and we can start working through this one. So let's start with this blue rectangle. This is the rectangle on the bottom. And again, there's one on the bottom and one on the top. So we're going to add those two together. But we just need to find the area of one of them and then we can double it. So we have twice this 15 by 4 rectangle. And again, just to find the area of this, we're just going to multiply the two lengths together, since the area of any rectangle is just the length times the width. And let me be more careful here. We really want to write in the correct units. So this would be a 15 centimeter by 4 centimeter rectangle, and that will give us centimeters squared, or squared centimeters, since we're dealing with area, not volume. Volume would have 3 units multiplied together. And then from here, we're looking at the rectangle on the right and on the left side. So to find that, we will multiply 4 centimeters by 25 centimeters, and then we're going to double it since there's 2 of them. So 4 centimeters multiplied by 25 centimeters will give us the area of each of these rectangles. And then lastly, we want the area of the front face and the back face, which is harder to draw in. But each of those rectangles are 25 centimeters by 15 centimeters. And there's 2 of them, so we'll double it. So that's 15 centimeters times 25 centimeters. And again, this just gives us the total surface area. And surface area, sometimes you can just call that SA. So our total surface area, SA, is equal to this equation here. And let's slowly calculate this. So 15 centimeters by 4 centimeters, that's 60 square centimeters. And again, we're just going to double that at the end. And here we have 2 rectangles, 4 centimeters by 25 centimeters, so that's 100 square centimeters. And lastly, we have this 15 by 25 centimeter rectangle, and there's 2 of them. So if we do 10 times 25, that's 250. 5 times 25 is 125. We add those together, 250 plus 125 is 375. And as always, when finding surface area, you're going to end up with square units if you're doing it correctly. So now we just need to add all these together. So let's first start by doubling everything. So we have 120 square centimeters here. We're going to add that to 200 square centimeters here. And doubling 375 would be 750 square centimeters. So this makes 320 when we add these together. Adding 320 to this would bring us to 1,070 square centimeters. So in conclusion, the total surface area of this rectangular prism, this cereal box, is 1,070 square centimeters. And you might wonder, what is a practical application for surface area? And this example is a good indicator of that. So you could ask the question, how much cardboard do you need to actually build this cereal box with these exact dimensions? And you would need this much area of cardboard. Or in other words, to make this cereal box, you would need 1,070 square centimeters of cardboard.